Okay. Um, the recording of this webinar will also be available on the Verdantas YouTube page by tomorrow morning. This webinar is scheduled for 1 hour. This includes our complete presentation as well as time allotted for Q&A. You'll notice that the comment section is disabled. However, we encourage you to submit any questions you may have using the Q&A module at any time during the presentation, and we will answer as many questions as time allows. So with that, let's get started. I'll now hand it over to John.
Thanks, Christina. First, I'd like to take a moment to offer a warm welcome and thank everyone for their interest in our webinar today. My name is John Stofflet. I'm a senior eco-engineer with Verdantas and have been with our legacy company, CBEC, for almost 16 years now. Most of my career is focused on river and floodplain rehabilitation, with some of my larger projects being associated with levee setbacks on the West Coast. I'm now located in my home state of Indiana, and today I plan to share some information about our recent work with the Nature Conservancy on the Wabash River. My colleague, Luke Tillman, who will also be presenting today, has about 9 years with Verdantas or CBEC, and is currently serves as our group's lead software development manager. He's also a principal developer of the Ecological Floodplain Inundation Potential Tool, which we term EcoFIP, and he's going to share some information on how it's being used to facilitate multi-objective floodplain planning and management. On the right here, we have a basic agenda for today's webinar. As I mentioned, Luke and I will be sharing some technical information, followed by a short presentations from our panelists that will highlight some project examples from the Wabash and Sacramento Rivers. Following the presentation, as Christina mentioned, hopefully we'll have plenty of time for questions. I'd also like to take a moment to introduce our panelists. Carrie Parmenter serves as the Lower Wabash River Project Director with the Nature Conservancy. Carrie has a background in agricultural and natural resource conservation, and she'll be talking today about her work on the Wabash River, where she's been making some huge strides recently towards implementing conservation within the watershed. And finally, Jacob Katz is a lead scientist with California Trout. Jacob has a background in aquatic ecology. He's a self-proclaimed fish squeezer and plans to share some insights on the importance of floodplains on the Sacramento River in California's Central Valley and some of his work towards restoring the ecological function on those floodplains. I'm going to hand it over to Luke to talk a little bit about multi-objective floodplain management and the EcoFIP tool.
All right, thanks, John. I'm going to advance the slide here. I first wanted to kind of define the problem that we're trying to solve with this tool and then get into a bit of how it works at kind of a high level, dipping into some of the technical details, and then passing back off to John to look at that in a little bit more detail on the Wabash River before Carrie and Jacob join toward the end. And I wanted to start with a little bit of history about the relationship that humans have had with rivers throughout human history, but especially over the 20th century in the United States. And a lot of the things that we're combating now are the fact that we've largely confined our river systems with levees, berms, and dikes and separated them from their historic floodplains. We've also dammed the headwater tributaries that feed into these for purposes of flood control, water supply, sediment management, and other reasons. And we've diverted significant volumes of flow out of these rivers to feed growing cities and croplands in lowland areas. We've also dealt with kind of a history of deforestation and mining on a lot of these areas. There's a lot of valuable aggregate materials that are pulled out of floodplains, and a lot of these river corridors are left behind in pretty impaired states. And we've also ditched and drained significant portions of historic wetlands that used to inundate and maintain water for many months out of the year. Now those drain very quickly to make them more suitable for growing crops. We're also confronted with aging infrastructure in a changing climate and trying to think about how we manage our systems in a time of increasing flood risk, and the fact that some of our most vulnerable human populations are disproportionately affected by floods and other aspects of climate change in living in these floodplain areas. And so we think of multi-objective floodplain management as kind of a multi-pronged solution to all of these multifaceted issues. Instead of just a historical focus on rivers for flooding or flood control or navigation work or water supply, we kind of broaden our scope of services to think about how do we restore geomorphic complexity of floodplains? How do we reconnect rivers to their historic floodplains, allow them to move around, move sediment, and be more free than we've allowed them to be ultimately? This promotes things like habitat uplift, bringing back large swaths of floodplain and channel habitat for fish, amphibians, birds, and all the food webs that support them. But we also still continue to think about flood risk reduction in ways that we're modifying these rivers, reconnecting to floodplains, still a really big driver of this is still reducing flood risk for downstream communities. We're also allowing water to get more out onto the floodplain where it can sit for longer periods of time, slow the flow, and treat these areas as big sponges that can help recharge depleted groundwater aquifers. And we can also think about the benefit of floodplain wetlands for processing nutrients in impacted river systems. And all of this gets at this idea of landscape rehabilitation, where we might not be able to restore a lot of these areas to some kind of historical condition based on patterns of human settlement and the realities of our modern lives. But we're able to try to find optimal solutions that both continue to support our human populations as well as the ecosystems and environment that supports us. But that brings us to another problem, and that kind of brings in the planning problem ultimately. We have a lot of tools out there to help us identify where we might want to do multi-objective floodplain restoration and management, but there are historically gaps in actually trying to get there. There's one suite of tools that I think of as kind of these large-scale GIS tools. These use digital elevation models and other widely available GIS data to provide broad metrics and a high-level understanding about where our priority watersheds might be, what types of issues we might be facing, whether it's loss of biodiversity or nutrient contamination, flood risk, and other things. But these are operating at a very high scale, kind of our 30,000-foot view. These have relatively simple data inputs and can therefore be applied over huge areas. Some of these analyses can span the continental United States, but as a result, the details that you get out of it are quite coarse and hard to draw site-level understanding from these types of models. At kind of the extreme other end, you have these detailed eco-hydraulic analyses that use 2D hydraulic models and pixel-based calculations to look at geomorphology and habitat indices at a scale maybe approaching a square meter or so in size. These are very detailed, require a high amount of data, complexity to put in, and you similarly get a large amount of detail of site-level understanding out of these things. But due to computational resources and other drawbacks of those data, it's not feasible to apply these over huge spatial scales or for long periods of time. And so there's been this gap in the past where we can use tools to identify priority basins. We have a lot of workflows to help us deal with engineering design, but not a lot has existed to kind of facilitate that transition. And that's really where we see EcoFIP fitting in. So EcoFIP, again, is the Ecological Floodplain Inundation Potential tool. Here we're using flow records, GIS data, and hydraulic models to identify, prioritize, and assess multi-objective floodplain restoration opportunities. And the way that we kind of fill in that gap, and knowing that EcoFIP isn't trying to replace either of those buckets, but really put in a middle ground that allows us to combine all three of them in a single workflow, we break up this funnel as we think of EcoFIP into these three different tiers of analysis. Tier one is our large-scale inundation potential. So this is looking at the hydraulics and topography of a river system and thinking about where we can get water out onto the floodplain, thinking about things like levee setbacks, floodplain lowering, or other interventions we could take, and thinking about the physical ability to get water out there. Tier two kind of digs in a little bit and asks the question of not only where can we get water, but how suitable is that inundation for a variety of purposes. Different areas might be more suitable for recharging groundwater aquifers. Some areas might provide certain types of habitat for fish, while others provide it for wetlands and shorebird species, for instance. And then we ultimately use this kind of multi-objective site identification and prioritization to identify where those sites are that we want to hone in on, that by the time we get to tier three, we're able to specify a few different concepts and think about what are the actions we could take at these high priority locations and what kind of benefit do we see if we do those. So I'm going to show a couple of the types of data sets that go into EcoFIP and come out, and then we'll step in a little more detail in the following slides. But we're ultimately starting with a digital elevation model, which is showing our topography of the river system, as well as a hydraulic model. And from those data sets, we're able to pull out a series of maps within tier one that ultimately describe how the floodplain inundates as a function of flow or discharge in the river. This gives us a good understanding of our physical inundation potential, as we talked about. But then when we get into tier two, that's where we break up the landscape, bring in our hydrologic record, and think about not only the spatial extent of inundation, but the timing, the seasonality, the duration of these inundations, the depths, and how it combines with things like aquifer properties, soil types, land cover, and a whole host of other GIS data sets to create these heat maps of our different opportunities within the river corridor. That allows us to identify these high priority sites that we carry forward into conceptual design iterations. And ultimately, we kind of move through this whole process to very quickly get us from a high level understanding of our watershed to site level conceptual design that we can then carry forward beyond EcoFIP into engineering design to actually implement projects on the ground. So stepping into each of these tiers with a little bit more detail, tier 1, as I mentioned, is our large scale inundation potential step. And this is going to show an animation from a portion of the Sacramento River showing how these different data sets get pulled out. And so I'm going to kind of animate through this video that's showing flows of 10,000 CFS up to 80,000 CFS in the river and back down. And this covers a range of expected hydrology for this portion of the Sacramento River. On the left side, we see water surface elevations are getting pulled out from our hydraulic model and extended across the floodplain through any sort of barriers, including levees or other high ground, to start to create these other maps. So height above river, this is showing the height of the land surface above the water surface elevation. Anything in blue in this animation is showing areas that are below the river level. Anything in green is up to 5 feet above it, and the browns and blacks are 5, 10, 15 feet above the water surface elevation. So height above river gives you a sense at each flow of what could potentially inundate, but also how far away you are from being able to inundate if you're thinking about floodplain lowering as a potential strategy. Depth is the inverse of height above river, and it becomes a really important determinant for habitat quality that we think about. And then we can also think about the connectivity of that inundation. So in this animation, anything in blue is physically connected to the river corridor at these flows. Anything in red could connect at those flows, but are currently disconnected by high ground. These often light up things like oxbow lakes and historic channels. And we also think about habitat suitability for different species based on depth and season and duration of inundation. All of that kind of feeds into tier 2, where we're looking at these multiple objectives, which might include habitat suitability for a range of fish, birds, or other species. Also thinking about nutrient processing and based on soils and nutrient concentrations coming in, as well as inundation dynamics, where we might have the greatest opportunities to remove nitrogen and phosphorus from the water column, as well as thinking about areas to promote groundwater recharge, as well as a whole host of other GIS layers that can come into these types of prioritizations in tier 2, some of which John will share for the Wabash example. And that finally gets us to tier 3, which is where we can get to a portion on the ground, delineate a high-level concept in GIS, have EcoFIP develop a concept surface out of it based on activation thresholds that we specify and target depths that we're looking to achieve, and then ultimately quantify the uplift. How much additional habitat are we getting for a certain species, or how much additional groundwater recharge, how much flood risk reduction are we getting as a result of doing this project, and what did it cost us on a rough order of magnitude to get there, so that we can quickly run through and prioritize these different concepts. We've applied EcoFIP to about 1,300 river miles of river throughout California and the Midwest so far, and the two that we're really going to focus on today are the Wabash River on the Indiana-Illinois border, as well as the Sacramento River for the String of Pearls project. So with that, I'll pass it back over to John to get into the Wabash.
Thanks, Luke. So a little bit about the Wabash in our work with the Nature Conservancy. TNC's overall goal on the lower Wabash is to enhance the ecosystem function of the river corridor, but also reduce the nutrient loads to downstream water bodies as a part of that. So we were tasked with developing a comprehensive plan to prioritize and implement future environmental actions within the entirety of the watershed. The project had 3 main components, the first being stakeholder outreach, which was used to better understand the problems that exist within the watershed and kind of to gauge an awareness of conservation practices amongst the landowners. And then we performed a BMP assessment for looking at agricultural BMPs that were aimed to reduce nutrient loads at its source with on the field and edge of field practices. Today, I'll be focusing on the use of the EcoFIP tool and how we used it to prioritize floodplain restoration projects along the lower 250 miles of the river to help achieve some of these overall goals. Just a little bit about the Wabash River for those of you who may not be familiar with it. It drains most of the state of Indiana. It's the longest free-flowing river east of the Mississippi. It has high biodiversity, but also gets the award for some of the highest nutrient yields in the Mississippi River watershed. This is primarily due to high agricultural land use, but partially also due to the lack of impoundments that would otherwise enhance nutrient processing on the river. So the peak area, the pink area on the graphic on the right shows the domain of our study area for the EcoFIP analysis that we're going to be talking about in the next series of slides. So Luke covered the 3 tiers of EcoFIP and emphasized the importance of tier 1, which really works to quantify that inundation regime of the floodplain, both on the wet and dry side of any levees that may exist along the river. So I'm going to mainly focus on tiers 2 and 3 on the Wabash, where we are leveraging our understanding of that floodplain inundation through the tool under tier 1 and relating that to habitat suitability, which serves as the basis for our prioritization scheme for floodplain restoration. On the Wabash, we use waterfowl, shorebirds, and a general floodplain wetland as the 3 metrics for habitat suitability. These can vary depending on which ecoregion you're working in. If you're working on the West Coast and are primarily concerned with salmonids and rearing habitat, you would have a different set of suitability criteria than we would here in the Midwest. So for waterfowl, we're focusing on foraging depths during the spring migration, which is a critical period during their life cycle, and it's heavily used within the Wabash River Basin. We are also considering shorebirds during both the spring and fall migrations, and then we have a general floodplain wetland metric that is year-round and has a broader range of depths up to 6 feet. So habitat suitability is expressed in terms of annual average days of inundation, and we apply a score from 0 to 1, with 1 being the longest duration. So that's kind of at a very basic level how we look at HSI scoring for the 3 different categories on the Wabash. Under tier 2, we also use other geospatial data sets or can use other geospatial data sets to further refine the prioritization scheme. On the Wabash, we developed a scheme which strives to ensure compatibility with the NRCS Wetland Reserve Program requirements. This is using the same habitat suitability as the base for the 3 different categories, and then layering on other metrics such as parcel size, the presence of hydric soils, as well as proximity to other protected lands. On the Wabash, we had 3 main HSI sort of categories. One was based solely on habitat suitability. And then, as I mentioned, we had this NRCS criteria, which uses that HSI as its base. And then we had another custom scheme for TNC that was very similar to the NRCS scheme, but it was a little bit less restrictive in terms of the presence of acromineal leases, for example. So I'm going to go ahead and jump to some of the tier 1 and 2 output. On the far left of this slide, we're going to show the range of flows that are required to activate the floodplain under tier 1. This is termed potential activation, as it's looking through the levees or other topographic barriers to quantify that inundation regime of the historic floodplain. And then we layer on the habitat suitability for general wetland category, as well as shorebird habitat on the next couple of images to the right. Again, these are expressed in annual average acre days of inundation. As you move towards the green and blue colors, this indicates a higher score for that HSI metric. On this slide, we were focused on output from the TNC prioritization scheme. So this includes that HSI as its base, along with other types of geospatial data sets to further refine that prioritization. Again, the 2 graphics on the right here show the difference in that levees make along the Wabash River. The black areas in the center graphic yield a low score as they are currently disconnected from the river. They're behind the levees or on the dry side of the levee, whereas the potential graphic on the far right illustrates the opportunities that could exist on the dry side of those levees if some actions were taken to connect those areas to the river. So using TNC's prioritization scheme, we identified 106 high priority sites in the lower 250 miles of the river and broke them down into different categories based on general cost versus benefit. That cost is in basic terms of the ease of implementation, and the benefits being uplift potential per the prioritization scoring. So moving on to tier 3, one large site that really stood out amongst all the others in terms of habitat quality was the Fairbanks Landing. The map on the left here shows the site. We have levees that exist along the main stem of the river along the left bank that disconnect the northern portion of the floodplain from the river. As you move downstream in the direction of my cursor here, these levees sort of peter out and allow for local drainages to interact with the river. So we have a north-south drainage that flows into the river along this location here. So water would generally backwater up along this drain and allow an inundation would be limited along this drain with berms that exist. The other major feature of the site was an east-west berm that limited inundation that occurred in that northern third of the property or of the site. And you can kind of see that play out on the graphic on the right, where we have a reduced activation of that northern third of the site. Some of the concepts that we proposed that would improve the hydraulic connectivity between the river and the floodplain included breaching of the levee in several locations along the main stem of the river. There's some limited grading as well, combined with this shown in yellow. That would enhance connectivity between the main stem and oxbows that exist within the floodplain. And then also we plan to potentially breach levees along the interior drain, which would allow water to sort of interact between the river and that drain and the adjacent floodplain, as well as proposed breaches shown in green here, which would enhance the connectivity via backwater through this site, I guess, both laterally and longitudinally. So as we implement this concept within EcoFIP, we can see, especially in the graphic on the right, how the model sees that change in the inundation regime. So I'll flip back to the previous slide to show how we are increasing the duration and frequency of inundation on the site through the activation threshold. We also see this reflected in the general wetland HSI scoring, where we have an increase in the annual average acre days of suitable wetland habitat, especially for the northern portion of the site where we have that increased connectivity. When we compare this to the baseline condition across all HSI metrics, we see over 100% increase in the general inundation and wetland habitat and over a 300% increase in shorebird and waterfowl habitat. And again, these are expressed in annual average acre days of inundation, which illustrates how EcoFIP is able to capture the change as a result of the actions that we had taken in terms of the timing, duration of inundation by considering that historic hydrology of the river system. I'm going to go ahead and hand it over to Carrie to cover some of a little bit about how EcoFIP is being used by TNC to accomplish some of the broader goals that they have in the lower Wabash River.
Thank you very much for that, John. So I'm going to back up just a little bit and kind of go over how we decided to use EcoFIP and why that was the tool that we landed on. We had a plan that was a 2020 to 2025 implementation plan for the lower Wabash, and that was coming to an end obviously this year. And so we were looking at some of the different planning tools that were out and available for us to be able to look at the next 5 years and how we wanted to move forward with our implementation strategies. We have historically used the NRCS, the Natural Resource Conservation Service Wetland Reserve Easement Partnership, the REP program. And that's been the main way that we have moved some of the restoration projects forward and have been able to do 150,000 acres worth of restoration in the Wabash Basin. But we were coming to the point that we were realizing that our investments were not being met because a lot of those landowners and those properties that were high priority had already been enrolled in the program. And so we were trying to identify where there may be other potential sites that had not enrolled in that program that we might be able to do restoration on, which is what led us to the EcoFIP tool. So in addition to just doing the mapping, we also wanted to make sure that the plan that we were going to be implementing included the local communities. And so that's how we got to the landowner meetings and the landowner outreach. We really wanted to work with those local communities to find out what needs they had and what issues they were dealing with. And then we would be able to marry our technical mapping with what was going on in the local communities and then be able to create this implementation plan. So one of the things that came out of that was a need for better communication and better coordination across the basin. And so we did, part of our implementation has been to create this Lower Wabash Partnership. And as we were doing the mapping and we were looking at where we have floodplain restoration potential, we recognized that the Wabash River, especially the lower section of it, is unlevied, And so there is a lot of floodplain that is connected to the river currently, but a lot of the connection that we have is actually across the Ohio River and the Green River in Kentucky. And so we've actually expanded our project boundary to include the Green River in Kentucky and have moved forward with CBEC on or Verdantas on doing the EcoFIP on the Green River now also. And so we used what we had gathered from our landowner meetings and partnership meetings, what our partners are giving us as far as their priorities along with the mapping. And then we have created a series of planning modules that looks at the entire river system. So we're looking all the way from the headwaters down to the actual river itself, and trying to create a plan that is going to look at the whole river system. So through that planning process, we have come up with a series of 4 strategic approaches that we are focusing on. The second column that demonstrate best practices for floodplain restoration is where we're really using the EcoFIP tool the most. And that is, we are working with some of our partners to actually identify sites where we can go in and do implementation, do restoration, and then we will be using those sites as demonstrations to be able to promote those practices to our other partners that are working in this area. We realized early on that the Nature Conservancy is definitely not the only organization that's working in this area, but the Lower Wabash has long been ignored as a restoration potential. And that's really what I have found the EcoFIP tool has been the most useful for me to be able to show where we can do these demonstrations, where we can do this restoration to our partners and to funders so that we can bring additional resources to this area. And then the other on the strategically acquire and transfer lands column, we have actually used this tool to expand the boundaries of where we are currently doing the REP. So we have worked with NRCS to draw new boundaries and have actually expanded that to include some of these priority parcels that were identified through EcoFIP. So the last slide I'm going to share is just, as John had mentioned earlier, the excitement that this has generated. We have over 150 participants that have joined an official Lower Wabash partnership. We are actually in the process right now of filing for a 501c3 status to become a standalone organization so that all of these different partners, it's everything from private landowners, duck clubs, state, local, federal agencies, everybody has come together and are having monthly meetings. We have a wildlife habitat committee and then a soil health and nutrients committee that meets monthly. They've come up with a list of priorities that they are working on and are starting to actually implement some of these strategies. And it's just very exciting to see the momentum that is being generated. And EcoFIP was a big part of that.
Thanks, Carrie. Luke, such amazing demonstrations of such a powerful tool. My name is Jacob Katz. I'm lead scientist at California Trout, and I wanted to talk a little bit about the Sacramento Valley. We in the Sacramento haven't had a chance to implement the EcoFIP tool to the same degree that you just saw shared by John and Carrie and Luke, but we're funded to do so over 300 miles from the bottom of the large dam at Shasta. So it's the top of the free-flowing Sacramento River all the way down to where it joins the Salt in the San Francisco estuary. So 300 miles of delineation, of determination where the best remaining habitat is, and a really informed idea of what would be necessary to take that opportunity and potential and turn it into real habitat uplift. So the Sacramento Valley, as you probably all know, is the northern lobe of California's Great Central Valley, sandwiched between the great uplift of the Sierra Nevada to the east and the Coast Range to the west. slides just disappeared. Well, looks like they're advancing on their own. Interesting. So the Sacramento was approximately 2 million acres of wetland habitats previous to what we know it today as this incredible mosaic of agricultural production, right? The Sac and the San Joaquin together are really America's great fruit and nut basket, some of the most productive and lucrative farmland on earth. They're also the major conduit for water, which is the fuel of California's economy, the fourth largest economy on earth. So this is really a valley of multiple uses. But again, before it was this mosaic, this fabric of agricultural productivity and rural communities, it was a mosaic of different kinds of wetland. The Sacramento Valley, as most river valleys, large river valleys, really is the expression of water flowing through and interacting, with the landscape through which it flows. And in the Sacramento, as Luke was talking about, the vast majority of those adjacent low-lying landscapes that once accepted floodwaters in the Sacramento Valley no longer do so because of really ubiquitous and persistent levying. Now I can't advance. Let's see how it goes. Huh? So before us in the Sac Valley is this really conceptually very simple, but logistically very complicated objective, which is reactivating the floodplain. Understanding that this single word, drainage, really characterizes the change since European settlement of the Sac Valley. What used to be the slowing and spreading of water across a varied wetland landscape that supported an amazing flourishing of fish and wildlife. As many as 100 million migratory waterfowl, a million salmon returning on an annual basis. And with the draining of those wetlands where most of that primary productivity that supported such wildlife abundance was generated, we've been reduced to a mere sliver of that former abundance. And much of that comes with serious regulatory hurdles as we face trying to manage many endangered species within the Sacramento River ecosystem. So this idea of multi-benefit management of rivers and floodplains has really taken hold over the last 15 years or so. And it's been a great joy to work with CBEC and now Verdantas to start to understand how we can think of water management not as flood management or ecosystem management or aquifer recharge, but in a synergistic, common planning arena. And to do that, we've really come together, different interests, conservationists such as California Trout, with other conservationists, say the Nature Conservancy or Audubon or Point Blue, groups really concerned with waterfowl, as well as with the commercial fishermen, the sport fishermen, the flood planning agencies, the farming interests, and the water interests that deliver the lifeblood of those agricultural endeavors throughout the Sac Valley. And we've come around in calling ourselves the Floodplain Forward Coalition and really looking to change the way in which water interacts with this landscape of the Sac Valley. And in order to do that, we really needed to have tools, means that allow people to imagine what was really possible. Luckily, we also have some incredible precedent to show that even on a privately owned landscape such as the Sac Valley, that if you change the the patterns, the sequences of water interacting with that landscape, you can have population level consequences. And I'm speaking right now about the amazing response that we have seen over the last 30 years with the resurgence of migratory waterfowl in the Sacramento Valley and along the Pacific Flyway. And that happened as we started to mimic natural flood patterns, primarily on rice ground. There's 500,000 acres of rice grown in the Sac Valley. And historically, that ground was burned, starting in the late 1990s due to clean air legislation. That practice was banned, and flooding began to be the common means of rice growers to degrade or to get rid of the rice straw on their lands so that they could work up their soils and be ready to plant the next year. And although that was initially a regulatory change, it was driven by regulatory change, it didn't take very long at all for the ducks and geese that had been flying over what had been primarily dry rice fields during winter to recognize the incredible, um, oh, yeah, there we go, the incredible opportunity that these flooded fields represented, that these were um, floodplain wetlands. They might not look like the historical floodplain wetlands, but they provided the key sequences of biophysical conditions that in this case, you're looking at snow geese landing in a rice field that post-harvest and fall was flooded again, was inundated to several inches of water. And the ducks and the geese looked down beneath their wings and saw the wetlands bloom again and said, we know what to do with this. Here's this incredible abundance again that you can't only just see like this, you can feel it when 30,000 snow geese take off at dawn in one of our wildlife refuges or off these fields. You can feel your rib cage reverberate. But the science started to show that these wetlands weren't just critical for ducks and geese, that they were also critically important for salmon. And my own work was to really take the inspiration of the work done on farm uh, for waterfowl and say, well, those floodplain fields, those would have been the same floodplains that young fish would have been rearing on and swimming through on their way to the sea. Might that shallow water habitat, those mud puddles, be adequate or sufficient habitat for young juvenile salmon? And when we tested that, the two fish you see here, the top one is a young Chinook salmon that was confined to the leveed Sacramento River and its tributary, the Feather River, while the bottom one, exactly the same age, actually a couple days younger, was given access to a flooded field in Yolo Bypass in a portion of the Sacramento River floodplain for just 3 weeks. And so what we started to understand was not only was this floodplain, inundated floodplain habitat absolutely critical for shorebirds, for ducks, for geese, but it was also the means by which energy, food energy, sunlight trapped as vegetation out on the terrestrial floodplain. The flooding was the means by which that energy entered the aquatic ecosystem, the means by which it became accessible to fish. So flooding then becomes the mechanism by which the river can actually rebuild fisheries abundance. And if you want to, not take my word for it, you can actually ask the fish. Oh, let's see if this will play. Oh, there we go. Excellent. Success. So what you're looking at is just a juvenile salmon allowed. This is actually pictures of 10 different juvenile salmon allowed to rear in a flooded rice field during winter. And what you see is that these fish not only survive, but they thrive. They're doubling their mass every week. And the difference between this fish and the one you saw 5 weeks earlier there is the difference between life and death, literally. The size and the condition factor, the amount of fat, of energy that that fish has been able to attain from the river ecosystem is probably the best indicator. Its size when it hits the ocean is the best indicator if that individual fish is going to return as an adult. So what we're really talking about is a fundamental difference in the ability of the Sacramento River Valley to produce fisheries abundance. And that has a direct effect on California's ability to deliver water into one of the largest economies on Earth. So what is EcoFIP going to do? Well, we're planning to use EcoFIP. Let's see if we can get to the next slide now. We're planning to use EcoFIP to look at the potential for floodplain restoration along the entire 300-mile length of the Sacramento River. And that has brought together every different kind of interest. These are folks, that often in California would only meet in the courtroom. And now you have the water interests, the farm interests, the different kinds of conservation interests, the commercial fishermen, et cetera, all coming together saying, wow, more fish is good for everyone, right? That when we have a valley where ecological function restores the engines of natural productivity that allow fisheries to flourish, when we don't have these endangered fish at the kind of core of California's water management. Instead, we have a return to abundance that really frees up and enhances California's water security for farms and for cities. That is an alignment of our economic and ecologic outcomes. And more than any other tool, EcoFIP really allows people to see that, to imagine a landscape where we're not returning to some subjective idea of what's pristine. Instead, we're reconciling an idea of nature and natural process into the management of our rivers, our farms, our institutions. And that's really led to this ridgetop to rivermouth portfolio supported by this broad political coalition to create a $2 billion portfolio of different kinds of river restoration projects. These often have a flood component, a water recharge component, and an environmental component. But that multi-benefit synergy really opens up the possibilities for landscape scale implementation. And this is the piece I can't possibly overemphasize enough, is that if we don't change the world that these critters move through at a landscape scale, we have no right to expect a population level response. And it's tools like this that are process-based that can really allow us to get to that landscape scale reconciliation. And just really pleased to see and be part of its implementation at this next chapter of conservation. And with that, I'll turn it back over to you, John. Oh, well, I guess I should talk a little bit about string of pearls. Just very quickly, the string of pearls is the simple idea that probably only 1% of the once accessible floodplain is still accessible to these fish. But those areas within the wetted levied channel that are accessible are incredibly important if we're going to actually have that population level response. And it's only if we can tie them all together, if we can think about a project that moves along the entire 300 miles of the Sacramento, and that each one of those small projects is linked to the next, and therefore allowing these fish to have access to rest stops, to bug buffets, to access the remaining habitat and to enhance that habitat in a way that really can get us to a landscape scale. And so just a little eye candy, similar to what Luke did before, but this is just what we're starting right now in the Sac Valley, is doing the work to identify those places of highest return on investment and then move into the specific site specific conceptual and then engineering plans that would allow us to really change the world that these fish actually swim through. So with that, I will turn it back over. Thank you very much.
Well, that concludes our presentation for today. I think we have plenty of time for questions. If you weren't around for the beginning of the presentation, there's an opportunity to post questions in the Q&A button at the bottom of the screen. So if you have those questions, feel free to go ahead and submit those, and we can go ahead and filter through those questions and have them answered by our panelists or by Luke or myself. Let's see what we have coming in here.
Well, Carrie, I have to say that moving into the Green River, you'll definitely have the best theme song going. I mean, that's can't plan that any better.
One question we have here is regarding nutrient, the ability to look at nutrients and to quantify, how much, nutrient maybe has been removed using the EcoFIP tool. Luke, I wonder if you could talk a little bit more about that tool and where it's at in its state of development and what its capabilities are.
Yeah, so some of these modules that we've had in EcoFIP have existed for longer periods of time. One of the first ones that we added beyond just looking at floodplain inundation was kind of that habitat suitability module that we've used to look at things from salmon habitat, as Jacob was talking about, to the wetlands and waterfowl and shorebird work that we've done on the Wabash. We've also looked at groundwater recharge in other areas, and then the nutrient module has been our most recent one that we've been developing. So this is of critical interest in the Midwest. John was showing some statistics about the Wabash being one of the greatest contributors of nutrient contamination to the Gulf of Mexico for various reasons. And the idea with this one is that the nutrient module kind of plugs in at each of those tiers of analysis within EcoFIP. So if you're looking at kind of a prioritization level, you're thinking about how often and for how long do sites inundate? What are the types of soil characteristics that are there? Maybe 8 or 10 different metrics associated with that lends itself to different abilities to process nitrogen and phosphorus and support microorganism communities that do that work. And then you can think about the incoming load within the stream. So you can, at that tier 2 level, kind of get an understanding of, based on 10 or 12 of those different variables, where do we think those high priority pockets are that if we do restoration there, we have the right conditions to support being able to remove nitrogen and phosphorus. And then when we step into tier 3, there's also that quantification of if you were to do a series of these projects that are certain sizes and you have the footprints of them, we can track how much water is going onto those floodplains over time, how long it's sitting there, what the residence time looks like, what the land cover and soil characteristics are, and you can make approximations of what the effect of that string of projects is having on the amount of nitrogen and phosphorus that are getting kind of transmitting downstream. So with that Green River project in Kentucky, starting to look at kind of the tier 2 prioritization level of the nutrient module.
Thanks, Luke. And just one thing to add to that, we are, I guess, in the process of preparing a manuscript for publication on that nutrient module. We're pretty excited about its potential application. So I guess for those of you who dabble in the peer-reviewed literature, be on the lookout for that, hopefully in the next few months. So let's see, another question here. Talk a little bit about specific projects where you used EcoFIP to identify aquifer recharge potential, both through the tiers 1, 2, and 3. Luke, do you want to fill that one as well?
Yeah, so this one, there have been quite a few projects in that map that I showed of the 1,300 river miles throughout California and the Midwest. This groundwater recharge potential is really of interest in California specifically. I mean, there's been a lot of studies looking at how we manage water resources in California, especially thinking about how we continue to manage those in a changing climate and thinking about what kind of capacities do we have in our reservoirs, and what kind of things can we get away with in terms of conservation measures, how we change farming practices and municipal use. And there's still a pretty big gap in between the amount of water that is going to be available in coming decades to California and the amount that we need to conserve or bank. And we can't just continue to dam rivers and build reservoirs. There's not nearly enough surface capacity to do this. And we're pretty well versed in the types of impacts that activity has on streams. So one big interest is saying, well, how do we get more water into the ground? And a lot of that has focused on agricultural, what they call MAR, managed aquifer recharge, diverting water off of rivers during high flows, putting it out over large swaths of fallowed fields or fields that are not in current production or are out of season, and allowing that to percolate as much water into these aquifers as possible, knowing where you have pretty conductive soils. But there's also, there's kind of an issue of conveyance with that. When you get a large flood coming through, you're limited by how big your pumps are, what the capacity of those canals are. And even though there may not be as conductive of soils directly around rivers, that's where the water is. And so thinking about how do we look at floodplain restoration as a way to recharge those groundwater aquifers? Because if you're able to set back a levee by a few, maybe 1,000 feet or 500 feet for a section of river, you're able to take a pretty significant volume of water over days or weeks of flooding and drive that into groundwater recharge without having to think about so much about the conveyance of it. So there's a lot of projects. California Department of Water Resources has a FloodMAR kind of planning division that has been doing all kinds of subsurface mapping and really trying to identify these high priority areas and really bringing floodplain restoration in as one of those strategies to catch up with our groundwater overdraft problem out there.
I think it's a really important piece, Luke, that you're mentioning there, right? So the Department of Water Resources has been looking at FloodMAR from a recharge perspective. At the same time, we have these landscape scale projects and objectives looking for restoring ecological function, especially the not just getting those floodplains wet, but keeping them wet long enough to allow the ecological processes, the food webs to move carbon-based energy up through microbial, fungal, into invertebrate bugs, right? And it's those bugs that then make small fish into big fish that grow up small duck chicks. All of this stuff has to do with the first piece in understanding the connectivity of river channel and adjacent landscape, but then time. And EcoFIP is so good at showing that time, right? It takes time to create the ecological values, but it also takes time once that water is spread out to sink in. And these are pretty simple concepts in a lot of ways, right? If you speed all the water off the landscape, in California, where it doesn't rain all summer and where groundwater is always our greatest bank account, what you've essentially done is, you have all the debits, we're still pumping the water out, but we're not depositing, we're not putting it back in. And EcoFIP really does this amazing thing, which shows people the amount of time that water can stay out there on the landscape if you are thinking about both flow and the topography over which that flow is moving, as well as the different kinds of aggregate that lead to infiltration. And in that piece, just thinking about puddles, about puddle power, about the amazing capacity to get multiple benefits when we start to mimic those longer duration inundations. It's a great tool to not just see one, but to see all three. Flood protection, ecosystem uplift, and recharge from the same potential project.
Another question we have here, what recommendations do you have for sharing EcoFIP mapping data with the general public or stakeholders or landowners whose properties may be included in that analysis? Carrie, you want to field that one?
That has been one of the challenges that we're trying to work through right now. Whenever we ran EcoFIP, we used parcel data to be able to identify the locations that we were wanting to work with. with the intent of being able to do landowner outreach then based on that parcel data. From the Nature Conservancy's internal controls that we have, I have run into some roadblocks with being able to share that private information outside of TNC. So we are actually in the process right now of trying to work with John on doing it more on a grid basis, so that we will be able to share that information without sharing the exact location or who the actual landowners are of those parcels. So that is still in progress, but we are working on trying to get some sort of outward facing tool that we would then be able to use for educational purposes and for sharing with our partners that would not violate any kind of privacy with landowners.
And for String of Pearls, which is publicly funded, meaning that the results of it are all public as well. So we don't foresee any issues with sharing with any interested parties. So just a different case there.
Yeah, I should mention too that the EcoFIP mapping can be done on a parcels basis, so we can look at these metrics and output at the partial scale, but it also can be conducted on a grid basis. So you can look at whatever grid resolution you want, basically within some limitations. So you can have that output on a grid basis, not tied to any one specific parcel. That might get around some of those issues that you have with sharing that parcel data out across public domain. So that's what Carrie's referring to in that conversion of the parcel to the grid-based output. So see what other questions we might have here. Another one for the Wabash project was related to the species that were considered as a part of that basic habitat suitability indices. How do we decide on which species to consider? I can field that one, I think, and Carrie, you can feel free to chime in. But I think that the emphasis there is that it could be, there's a lot of flexibility within EcoFIP. You can look at, individual species of concern. If you have an imperiled or a threatened endangered species that you're particularly concerned about in a particular system, you can look at specific habitat suitability. That's a function of that inundation, timing, duration, and frequency of inundation on the floodplain through the historic lens to look at that individual species, or you can look at groups or guilds of species as well. On the Wabash, we have that general floodplain wetland category, which was intended to get at some of that primary productivity that Jacob was mentioning, really that driver of the food within that riverine ecosystem, but also for the benefit of nutrient processing. So we looked at inundation year round, up to depths up to 6 feet, and then other species of concern or interest are definitely waterfowl. There is a lot of recreational hunting surrounding waterfowl, and there's a lot of conservation motivation within the Wabash River Basin for waterfowl hunting. Similar to the Sacramento River Valley, they have waterfowl hunting is a pretty big deal out there as well. So that, as a driver for conservation, is definitely a major consideration, and that the foraging, during the spring migration is a pretty critical period for food for waterfowl. And so we can look at specifically that, those specific depth range that are ideal for foraging during that spring migration, and when that occurs on the river, and when and where that habitat exists on the parcel scale. So that's, and shorebirds were also of interest. I can let our ecologists speak to the importance of, those shorebirds, but they are also a species of concern within the Wabash River Basin, as I know they are in California as well. But Carrie, anything to add on that one?
I would say that another factor that went into selecting waterfowl and shorebirds was funding, and the types of funding that we were planning to be going for based on the results of this. And so that was another factor that we took into consideration, because there is a fair amount of funding that is available for waterfowl and shorebird habitat restoration. And so that was just part of that thought process whenever we were selecting those.
Great. Well, we've reached the top of the hour, and as much as I'd really like to continue to answer additional questions, I really want to take the moment to thank again everyone for joining us today for this webinar. Appreciate your interest and attention. We also want to have a special special thanks to Jacob and Carrie for taking the time out to participate in that webinar. We really appreciate their input and insights today. If you have any other questions about EcoFIP or some of these projects that we've discussed today, feel free to reach out to Luke or myself. You can also use the QR code at the right to get more information. I think also to potentially download the presentation. I'm not sure about that one, but again, thank you again for attending today, and we appreciate your time and attention. Have a great day.
Thanks, everyone.